Hey, you guys, this video is going to be on solving single variable inequalities. So inequalities that only contain one variable. So in doing these problems, the first step is to really just ignore the inequality symbol. So I'm just going to make this into an equal sign because first I need to figure out what does x equal, which is called the boundary points. So to solve this, you have a couple options. You can distribute the 2 through and solve it that way, or you can divide by 2. Okay, so I am going to show, I'll just do the distribution and show that way. So 2x plus 2 equals 10. Subtract 2 from both sides. So that would give me 2x equals 8, and then divide by 2. And I get x equals 4. So once you get your boundary point or your boundary points, because there can be multiple, what you're going to do is create a number line. And I just like to say that you should have values surrounding your boundary point. So now this is where I have to pay attention to the inequality. Since it's just greater than, that is going to be an open circle at my boundary point. Then I want to figure out, well, are my answers bigger than 4 or are my answers smaller than 4? So you're just going to pick one of these values to plug into the original inequality to see if it is a solution or not. So I'm just going to plug in 3 just because it's a smaller number. So it would be 2 times 3 plus 1 is greater than 10. And I'm going to simplify. So 3 plus 1 is 4. So 2 times 4 is 8. So is 8 greater than 10? That is not a true statement, which means 3 did not work. So my solutions must be bigger than 4. Okay, so here is my number line representation, and then I also just need you to represent it symbolically, which would just be x is greater than 4. All right, next example contains an absolute value. So same process here. Let's just figure out what x would equal, and then we will worry about the inequality afterwards. So 4 absolute value of x minus 2 plus 6 equals 18. So I'm going to start by subtracting 6 from both sides. And then I need to get my absolute value alone, so now I'm going to divide both sides by 4. So I have the absolute value of x minus 2 equals 3. Okay, now this is where we have to set up our two cases. So the absolute value of 3 equals 3. So that means that x minus 2 could equal 3. But the absolute value of x minus 2, the absolute value of negative 3 would also equal 3, so that is my second case. And then I just solve these individually. So add 2 to both sides here would give me x equals 5, and adding 2 to both sides here would give me x equals negative 1. So now in this case, I have 2 boundary points. So I'm going to go to my number line. All right, so I have negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. All right, so at my boundary points, I need filled in circles or closed circles since it's less than or equal to. So the equal to down here is what makes it be a closed circle. So negative 1 and 5. And then at this point, I have to figure out, is the shading in between my 2 boundary points or is it on the outsides? So to do that, we're going to test a point. Now, I would suggest if you have 2 points, I always like to pick a number from the middle to see if that works. And if it doesn't work, we can assume that it's going in the opposite directions. So I'm going to use 0. You could use 0, 1, 2, 3, or 4. I'm just going to pick 0 because I think it's an easy number to plug in. So 4 absolute value, 0 minus 2 plus 6 is less than or equal to 18. So 4 absolute value, 0 minus 2 is negative 2. And then just copying the rest down. The absolute value of negative 2 is positive 2. So I have 8 plus 6. So 14 is less than or equal to 18. Okay, this is a true statement, so that means that 0 worked. So any solution or any number between my two boundary points and including my boundary points will work. All right, so here's my graphical or my number line solution, and then I also want to write it symbolically, which would look like this. So x is greater than or equal to -1, and x is less than or equal to 5. And one more example with that. Another absolute value one. So again, I'm going to ignore the inequality, and I'm just going to make this an equal sign. And I'm going to solve for my boundary points. So add 5. And now I have to set up my two cases. So 2x plus 1 could equal +9, or 2x plus 1 could equal -9. So subtracting 1 would give me 2x equals 8, and then divided by 2 would give me x equals 4. So 4 is one of my boundary points. And then same process over here. Subtracting 1, -9 minus 1 is -10, and then dividing by 2 would give me -5. So I'm going to make my number line. And I'm going to be kind of lazy with this number line, just for time purposes. Okay, so I have some numbers on the outsides of them and some numbers on the inside. All right, I need open circles at my boundary point since it's just greater than. So at -5, I have an open circle, and at +4, I have an open circle. And same process here. I would always just check a number in between first. If you don't want to, that's fine, but I just think it's a little bit more straightforward in that regard. So I'm gonna use 0 again. So I'm gonna check 0 in my original inequality. So the absolute value of 2 times 0 plus 1 minus 5 is greater than 4. So 2 times 0 is 0. And so I have 0 plus 1. The absolute value of 1 is 1. So I have 1 minus 5 is greater than 4, and 1 minus 5 is -4. -4 is not greater than 4. Oops, there you go. -5 is not, or I'm sorry, -4 is not greater than 4. So this is an untrue statement. So this point did not work, okay? Which means nothing in between these two boundary points will be a solution. So my solutions must be on the outsides. All right. So here's my number line or my graphical representation. And then my symbolic representation is x is less than -5. Okay, so that would be representing these solutions. Or x is greater than 4. So above 4 would be representing this side.